In today's video, we were talking about the Newman projection. The Newman projection can only happen for a single bond. This is because it can freely rotate. It cannot happen for a double or triple bond, because if you do rotate a double or triple bond, it will break. So if we have a structure like this, and I asked you to draw the Newman projection for looking at the third and fourth carbon, right? If we were to number the carbon, the parent chain would be 1, 2, 3, 4, 5, and 6. The sixth carbon, right? And so let's draw the condensed structure so we can have a better visualization for this. So we have carbon 3 over here attached to the carbon 4th. Now looking at the carbon 3rd, the back we got a 1, 2, 2 carbons. So that's a ethyl group, ethyl. So we CH3C. Oh, right, some more space for this. It'll be so it'll be connected to a CH3CH2. Right. Now, on the third carbon, we have a methyl group down here. So it would be CH3. Now, carbon can have 4 bonds. There'd be a hydrogen over here because according to this carbon, it has 1, 2, 3. The fourth carbon, the fourth bond is the hydrogen bond because carbon can have 4 bonds. Now, looking at the fourth carbon, the back we got carbon 5 and carbon 6. So that's 1, 2. 2 carbons. That's an ethyl group, ethyl. So carbon 5th has 2 hydrogens, while carbon 6 has 3 hydrogens to it. Now, on top of this is a hydrogen down here. This is because carbon can have 4 bonds, so it has a hydrogen over here, so that's 1, 2, 3, 4. 4 bonds. Now, we can draw the Newman projection for this, so all we do, draw a circle. Before we do that, we got to determine, well, not determine, but we know that the third carbon is the first one, so that'll be the front carbon. I'll indicate there's that front carbon right there. Right. Now, in front of it, right here, is the ethyl group. So we would write CH3CH2. It's connected to what? Well, a methyl group on the left. It doesn't matter which side, but I'm just drawing it through the condensed structure. And a hydrogen over here. Now, there's a back carbon. The back carbon is the fourth carbon, the second one. So we can't see it, but it's there. So it'll be on the sides, right? So we have on the side, we have the hydrogen, and we have the ethyl group, the CH2CH3, right? This position right here, this is called the staggered. This is staggered. This whole thing right here is in the staggered position. Staggered position means it is less, well, not less, but let's say more stable. It's stable, so it's most stable. By having it to be more stable, it would have a less energy. We'll get to the energy part later. So it's less energy, right? Now, when we draw the Newman projection for this, we'd always rotate to the right 60 degrees. Always to the right 60 degrees. Never to the left. So we have a choice of either rotating the front carbon, which is the third carbon, or the back carbon, which is the fourth carbon. So in this case, we'll move. It doesn't matter what you move, but your professor might ask you which one to move. So for this video, we will going to be moving the front carbon. So the third carbon. So we have draw another one. So we know that the back carbon will never change if you change the front carbon. So the back carbon always stays the same, right? CH2 and CH3. Okay. Now we just change the front carbon rotating 60 degrees. So this ethyl group will be on top of the hydrogen. Okay, so it's looking like this. CH2. This hydrogen will be top of this ethyl group. It's literally on top, but to see it, you have to write it close to each other on the side. And this methyl group would be on top of this hydrogen, so CH3, right? This form right here is called eclipse. This whole thing is called an eclipse form. Right, now eclipsed, just write that so you guys don't get confused. Eclipsed is less stable, but being less stable has more energy in it. Energy. And so for this, we will withdraw. And before going on, we should see some key points right here. For seeing this and this on the first Newman projection, this is called anti. This means they're the bulky groups, the big ethyl groups are on the side, are on top of each other, 180 degrees. They're far apart from each other. That's anti means, it just means they're less stable, but it always happens on the staggered position. Okay, now if we had to draw the third, let's just erase this. We have to draw the third Newman projection for this. So the back carbon always stays the same. Let me just move it up a little bit, you guys to see. Oops. Okay, I have to draw the third Newman projection for this. The back carbon always stays the same, so H and H, and then we have the CH2CH3. Now it rotates again, so now this methyl group would be on top, 60 degrees rotation. On the side we would have the hydrogen. Right, on this side we would have the ethyl group. Now there's an important key right here, CH2, right here. This is called gauche. This means less stable. Okay, it happens when two carbons come close to each other, right? But these two are the biggest ones, bulky groups in this formula. So that means it's even more stable because you have the bulky groups. Okay, so this is less stable, and this will be the third Newman projection. This was the first, and this was the second. Okay, I'm gonna have to erase some now. So let me erase this. So we can draw the fourth, fifth, and sixth Newman projection. Now going on to the fourth Newman projection, you have another circle. It's a horrible circle, actually, to be honest with you. You have the fourth circle. So, as I said, the back carbon always stays the same because we're only rotating the front carbon. So CH2, CH3. Now, this ethyl group will be on top of this ethyl group. This hydrogen will be on top of this hydrogen. Okay, and then this ethyl will be on top of this ethyl. So now this is the eclipse form. But now look at this. We have two of this bulky groups on top of each other. So this is by far, this is the fourth. This is the fourth least is stable. So it's the most, no, least stable, right? So having least stable will have the highest energy. So this has the highest energy, the fourth one. Energy. Okay. Has the two bulky groups. We want the two bulky groups to be separate from each other, but in this case it is. Now we have to draw the fifth one. You know, the back carbon never changes, right? and this would be CH2, CH3. Right, now the front carbon goes over here, CH2, this is the ethyl group, CH2, comes with a CH2, CH3 is the methyl group, because of this, goes over here. Now on top is the hydrogen. Okay, so you can see the pattern, how the pattern goes and whatnot. Now we have a problem over here as well. We have this, and we have this. We have two gouge, right? Two gouge. On the third Newman projection, we only had one, which is less stable. We have two over here. So this is even more less stable than the third one. Less stable because of two gouge. Okay, less stable. So this will be the fifth. Oops, this will be called the fifth. Right. So the fifth Newman projection has a higher energy than the third one, but is even more less stable than the third one. Okay. So now one more Newman projection, which is the sixth Newman projection. Right. So the back carbons do not change. They stay the same. CH2, CH3. Now rotation one more time to the right. 60 degrees. So this methyl group will be on top of this, of this hydrogen. CH2. Okay. Now this methyl group will be on top of this ethyl group. It's on top of each other, okay? And then this hydrogen will be on top of this hydrogen, right? So this is the sixth Newman projection. Now, we see here also the eclipse, and we have two carbons on top of each other, so makes it less stable, but it isn't worse like this. This is the bulky group. This is even more or less stable than this because these two are the most bulky groups, the biggest groups. The ethyl's on top of the ethyl, while this is just methyl on top of the ethyl. So this has higher energy than this, and this is less stable than this. But this is the sixth Newman projection.